Welcome back to G Fun Facts Online. Today we are digging deep, literally. If you were to design a creature specifically to haunt the nightmares of the squeamish, you might craft something that looks remarkably like a snake but is not one. You might give it a body that moves with the relentless piston-like drive of a worm, yet grant it a skull as hard as granite. You might decide that this creature should live in the dark, slimy underbelly of the tropical earth, and perhaps, for a finishing touch of horror, you would design it to feed its young with its own living flesh. If you did all of this, you would have designed a Caecilian. However, to dismiss the order Gymnophiona as merely the stuff of nightmares is to overlook one of the most evolutionarily successful, anatomically bizarre, and behaviorally complex groups of vertebrates on our planet. For millions of years, while dinosaurs rose and fell and mammals scurried in the shadows, these so-called naked snakes were perfecting the art of the subterranean life. They conquered the wet tropics of the world with a toolkit of biological innovations that science is only just beginning to understand. This is not a story of a primitive remnant of a bygone age. This is the story of a highly specialized, venomous, skin-eating, milk-producing burrowing machine that has managed to keep its secrets hidden beneath our feet for eons. This is the secret life of the legless amphibians. To understand the Caecilian, we first have to grapple with a ghost. For over a century, herpetologists and paleontologists have fought bitter academic wars over where exactly these creatures fit into the tree of life. We know they are Legless Amphibians, a group that includes frogs and salamanders, but they are the estranged cousins who left the family reunion early and took a very different path home. The fossil record of Caecilians is notoriously poor. This is a result of their delicate small bones and the acidic tropical soils they inhabit, which are terrible for fossilization. For decades, the oldest known Caecilian was Caecilia micropodia, a creature from the early Jurassic of Arizona. Caecilia was a missing link made manifest because, unlike modern Caecilians, it still possessed tiny vestigial legs. It was a snapshot of a transition, a moment in time where a salamander-like ancestor was descending into the mud, trading limbs for leverage. But Caecilia also deepened the mystery. By the Jurassic, it was already highly specialized. So where did it come from? The answer may lie in a controversial fossil named Chinlastegophis jenkinsi, discovered in the Triassic rocks of Colorado. Described in 2017, this creature suggests that Caecilians are the last survivors of the stereospondylus, a group of crocodile-like amphibians that dominated the waterways of the Triassic. If this hypothesis holds, Caecilians are not just weird frogs. They are the enduring legacy of a lineage thought to have been wiped out 200 million years ago. They are living fossils in the truest sense, carrying the anatomical blueprints of a pre-dinosaur world in their skulls. When we look at where they live today, the distribution of modern Caecilians is a living map of the ancient supercontinent Gondwana. They are found in South America, Africa, the Seychelles, India, and Southeast Asia. These are fragments of a once unified landmass. When Gondwana began to tear itself apart during the Jurassic and Cretaceous, Caecilian populations were rafted away on drifting continents. The connection between African and Indian Caecilians is particularly telling. The family Caecilidae, recently discovered in northeast India, diverged from its closest African relatives around 140 million years ago. This happened just as the Indian plate began its long, lonely voyage north across the Tethys Ocean. This makes the Caecilians of India not merely local amphibians, but ancient immigrants that rode a tectonic arc for millions of years before crashing into Asia. Now, let us look at the animal itself. A Caecilian is not simply a tube. It is a masterpiece of bioengineering designed to solve a specific problem: how to move through a medium that is heavier and denser than yourself, without using arms or legs. The head of a Caecilian is a battering ram. Unlike the open, lightweight skulls of frogs, the Caecilian skull is stegocrotaphic, which means it is solidly roofed with bone. Over millions of years, the temporal openings found in other tetrapods have closed up, and the individual bones have fused together to form a rigid, bullet-shaped helmet. This ossification allows the Caecilian to perform headfirst burrowing. The animal rams its snout into the soil, compressing the earth, then uses its internal muscles to pull its body forward. But a solid skull presents a problem. Where do you put the jaw muscles? In most animals, jaw muscles bulge outwards when contracted. In a tunnel that fits your body exactly, there is no room for bulging cheeks. Nature's solution in Caecilians is the dual jaw closing mechanism, a feature unique among vertebrates. Like other animals, they have adductor muscles to pull the jaw up, but they also have the interhyoideus posterior. This is the game changer. Caecilians have co-opted a muscle from the neck and attached it to a lever on the back of the jaw. When this muscle contracts, it pulls back on the lever, swinging the jaw shut with immense force. This system allows the Caecilian to keep its head sleek and streamlined, while still delivering a bite powerful enough to crush the chitinous exoskeletons of termites or the bodies of earthworms. It is a biting mechanism designed by a claustrophobe. Behind that battering ram of a skull lies a body that moves like a piston. The skin of a Caecilian is not attached loosely to the muscle as it is in a dog or a human. Instead, the skin is largely independent of the trunk muscles. The animal moves using internal concertina locomotion. The vertebral column bunches up inside the skin, anchoring the rear of the body, and then pushes the head forward. Then, the skin is pulled up to meet the head. It is a movement of eerie smoothness, allowing them to traverse tunnels without the friction that would stop a snake in its tracks. To navigate this dark world, Caecilians have evolved a unique sensory organ found in no other animal: the tentacle. Caecilian eyes are a study in regression. In many species, they are tiny, covered by skin or even buried beneath the skull bones, capable of detecting little more than light and dark. To navigate the eternal night of the subsoil, they rely on this retractable feeler located between the nostril and the eye. But it is not just a tactile probe. It is a complex chemosensory device. The tentacle is lubricated by the Hardarian gland and is connected to the vomeronasal organ. The Caecilian extends the tentacle, touches the soil, retracts it, and wipes the chemical cues directly onto its sensory array. It is, effectively, a way to taste-touch the world, allowing them to track earthworms through the dirt with the precision of a bloodhound. Now, we must address a recent discovery that shook the biological world. For decades, the dogma was clear: amphibians are poisonous, meaning they have a passive defense, but not venomous, meaning an active delivery system. A poison dart frog will kill you if you eat it, but it cannot inject you. Snakes, on the other hand, are the masters of venom. In 2020, this dogma was shattered by a team studying the ringed Caecilian, Siphonops annulatus, in Brazil. They discovered glands at the base of the teeth, not the skin, that produced enzymes similar to those found in snake venom, such as phospholipase A2. Even more shockingly, these glands originated from the dental lamina, the same tissue that gives rise to the venom glands of vipers and cobras. This discovery rewrites the history of venom. It suggests that the oral venom system might be an ancient trait of early tetrapods, predating the snakes by 100 million years. For the Caecilian, this venom is likely a tool for subduing prey. Earthworms, their primary food, can be surprisingly strong and fast in their own burrows. A quick injection of a paralytic or digestive toxin turns a struggle into a meal. The naked snake is, in fact, a venomous predator. If Caecilian anatomy is efficient, their reproductive biology is nothing short of science fiction. This is where the order Gymnophiona truly flaunts its diversity, employing strategies that range from the grotesque to the surprisingly tender. All Caecilians practice internal fertilization. Male Caecilians possess an intromittent organ called the phallodium. This fleshy tube, extruded from the cloaca, often has spines or hooks to anchor the male to the female during copulation, a necessity when you are two slippery tubes trying to mate in a muddy tunnel. But the real surprise comes after fertilization. In 2006, scientists observing the African species Boulingerula titana noticed something disturbing. The hatchlings were equipped with specialized, hook-like teeth that looked nothing like the teeth of the adults. They were not eating worms, they were eating their mother. This behavior is called maternal dermatophagy. During the brooding period, the mother's skin undergoes a transformation. It becomes paler, thicker, and rich in fats and lipids. The babies swarm over her, tearing off strips of this nutrient-rich epidermis with their hooked teeth. The mother stands stoically while she is flayed alive by her offspring, regenerating her skin every few days to provide the next meal. This extreme form of parental investment was later found in the South American Siphonops annulatus, proving that this behavior is likely an ancient Caecilian trait. Just when science thought it had seen the peak of Caecilian weirdness, 2024 brought a new revelation. Researchers studying Siphonops annulatus noticed that the skin-eating wasn't the only food source. The hatchlings would congregate at the mother's vent and emit high-pitched clicking sounds. In response, the mother would release a thick, white, lipid-rich fluid. Milk. Functional lactation, previously thought to be the exclusive domain of mammals, had been discovered in an egg-laying amphibian. The milk is secreted from hypertrophied glands in the oviduct. The acoustic signaling of the babies indicates a level of social communication and maternal responsiveness previously unimagined in amphibians. But what about the species that don't lay eggs? About 75% of Caecilian species are viviparous, meaning they give birth to live young. But they do not have a placenta like humans. Instead, the embryos develop inside the oviduct. Once they exhaust their yolk sacs, they do not sit idly. They use specialized fetal teeth to scrape the lining of the mother's oviduct, stimulating the secretion of uterine milk, which they consume. In some species, they may even eat the other eggs, or smaller embryos. By the time they are born, they are fully formed miniature adults, having passed their larval stage entirely within the womb. To fully appreciate these creatures, let us take a quick global tour of the major families. In South America, the Amazon is the kingdom of the Typhlonectidae. These are the aquatic Caecilians. Some, like Typhlonectes nitans, have shed the burrowing lifestyle for the water, developing a vertical fin on their tail. But the true monster of this family is a Trettochoana icelti. Discovered in the Madeira River, this animal can reach lengths of over 80 centimeters. It is gray, flabby, and eyeless. When photos of it first hit the internet, it was dubbed the penis snake for its appearance. But its anatomy is even more shocking. It has no lungs. It is the largest tetrapod in the world to lack lungs, breathing entirely through its skin. It lives in the fast-flowing, oxygen-rich waters of the Amazon basin, a giant wraith that suffocates if taken out of the water. In Africa, we find the Herpelidae and the bizarre Scolecomorphidae. The latter are the only vertebrates whose eyes are attached to their tentacles. When they retract the tentacle, the eye is pulled deep into the skull, beneath the bone. When they extend the tentacle, the eye pops out. It is a jack-in-the-box eye, an adaptation that protects the delicate organ while burrowing. In Southeast Asia, we find the Ichthyophidae. These are often considered the most primitive Caecilians because they retain a true tail, which other families have lost. They are often colorful, with bright yellow stripes running down their dark purple bodies. And in northeast India lies the territory of the Caecilidae, the ancient lineage that has been burrowing in the Indian subcontinent since the age of the dinosaurs. Finally, on the granitic islands of the Seychelles, we find the Grandisonidae. These island endemics include the petite Praslang Caecilian, one of the smallest in the world, growing to only about 10 centimeters. They represent a unique island radiation, evolving in isolation for 60 million years. Despite their global presence, Caecilians have existed on the periphery of human consciousness. In the folklore of the Himalayas, they are called backache snakes, feared because people believe merely seeing one can cause debilitating pain. In the western Ghats of India, they are often killed on sight, feared as being more venomous than cobras. In Brazil, legends of the Minho cow, a giant earthworm-like cryptid said to uproot trees, may have been inspired by sightings of large Caecilians. The only contact most Westerners have with them is through the aquarium trade, where Typhlonectes natans is sold as the rubber eel. They are popular for their oddity, but they are frequently kept in poor conditions, treated like fish rather than sensitive amphibians. This brings us to the final, somber chapter, the invisible extinction. Because they live underground and are hard to find, Caecilians are the data-deficient capital of the amphibian world. We do not know how many species have already gone extinct. We do know they are not immune to the threats facing their legged cousins. The chytrid fungus, the plague that has decimated frog populations worldwide, has been found on Caecilians. Furthermore, they are soil specialists. When a rainforest is bulldozed for agriculture, the soil is compacted, dried out, and poisoned. The complex ecosystem they rely on is destroyed. They cannot fly to a new forest. They are trapped in the earth that is dying around them. Caecilians challenge our bias towards the visible. We value the eagle for its flight, and the tiger for its stripes, but we ignore the tube of muscle moving through the dark. Yet, in the Caecilian, we find a creature that has survived mass extinctions, drifted on continents, evolved venom, milk, and skin feeding, all without ever seeing the sun. They are a reminder that evolution is not a ladder upward toward humans, but a branching tree, where success can look like a blind, limbless cylinder swimming through the mud. As we walk through the tropical forests, we must remember that the ground beneath our boots is not lifeless dirt. It is a frontier, and down there, in the roots and the rot, the naked snakes are living lives of quiet, slimy complexity. Thanks for listening to G Fun Facts Online.